Hi, good morning. Thanks for watching this stream. Today I'm going to be working more on the capital allocation Python code. I did some updating to it overnight so that you can, now it's a Python package. So here, just in the main repository, you see I was doing it there above. From BetRisk import, I'll just say the same thing as up there. Risk management is R, and then we have these things that we can manipulate. We have to define it. So you can make an event. Here, Rams, Lions, you're saying what percentage the book is taking because you're not a sports book. And then you have the odds for the first option, so Rams, and then the odds for the Lions. I'm leaving out all this stuff with home and away, hoping to simplify it. And yeah, you basically have events. You can add bets to an event, or you have two options for an event, and hopefully, or I want to add something into the event class that tells this is a good bet versus a bad bet. So I guess I'm gonna write all that in the chat. Good morning. Today I'm working on package that to manage capital allocation in sports betting. This should help sports bettors to minimize losses and maximize gains. Please ask questions. Okay. I hope that sent. Get rid of that. Okay, good. That sent. All right. Now, time to get down to business. So, I'm messing around with the code here. Okay, so I'm calculating the payout somehow incorrectly. We're putting $10 down on the Rams at plus 200. Now that should return $20, but it doesn't. So how do we get the 0.3 out of 200? Okay, so if odds are greater than 0, return 1 minus Parker's column. Alright, so 1 minus that. Alright, so let's just do a different thing. We're getting that payout of odds. We could say if odds, odds and then risk. If odds is greater than 0, it's the same thing. If odds is positive, return. So it should just be risk times odds divided by 100. Otherwise, if it's negative, return risk times, and then so if it's negative 200, 100 divided by minus odds. Yeah. That should be it. Payout now is equal to get payout of odds risk. All right, now let's get out of there. I think I saved everything. Let's just exit out of here. Where do we put tests in a Python directory? Python package organization tests. Might be at the top here. Okay, here the perk's gone. Oh yeah, tests. Okay, so if we go to tests, alright, so let's make a function called escape queue insert okay, and then we could say, what do we want to say about this? Test for the bet class in risk management .py. Dog. All right. From risk management, import get payout. Import everything. B is equal to bet, and the odds should be 200. We're gonna risk $10. It's at a 5% fee, so we're expecting to get paid out $20 and get hit 5% on that. So $1. So the payout should be $19. You know what? We may as well figure out how to do PyTest. I thought before that this is something I need to know how to do. I don't want to miss any chats, so I'm just gonna set a timer. Check every 15 minutes. 15 minutes of work, check the chat. Kobe about to lose 150 AMs. Alright. But you wasn't with me shooting in the gym? Okay. Alright, for my homie's dog. Documentation, get started. Okay, right, then quit. Pip install PyTest. That'll upgrade it. No, I don't think it did. Who cares? Containing a function and a test. Alright. Go back to here. Test. Bet. Define test profit. Alright. No, we could say here B is equal to bet 200 20 0.05. And then we're going to assert, because I'm the realest in this, y'all know it. Should be 19. And how money is flow money. Then that's what the fuck they got a shit blow money. Okay. Alright, and I'll say here B dot calc. Say fuck that shit, young fella get paid. Alright, then we want to assert. Oh, that already happens. Oops. Then we want to assert B dot payout is equal to 19. Okay, I think that's all we want. I don't see it all. Oh, should be a test. So, move bet.py to test bet.py. Honestly, no. Alright, so from risk management. From BetRisk. Insert. What is happening? Alright, now let's see if that works. Till the death of him. Alright. So for betting $20, no, for betting $10, it's just me and my guitar. Yeah, I'm heavy metal and so get payout. Is 12.6. So if we put $10 down, payout. Assert B.payout is 19. So we oh no, we threw down $20. So it should be even bigger. Okay, so put $20. The odds are 200. Odds are greater than 0. Risk is 20. 200 divided by 100. Okay, let's just do this. This is weird. Print odds risk. Return val is equal to equals, and then here we could just say return val. Escape, write, quit. Convert odds, get payout. Welcome, Dammy. Okay, let's just go into here then. Now we're in BetRisk. Whoa. I put that in the wrong place. Okay, whatever. From risk management, import all. Alright, now we have get payout 200. We're gonna risk 20, should be 40. Yeah. Alright, so B is equal to bet. The odds are 200 and the risk is 20. B dot payout is 40. So what's going on in PyTest? Oh. Open this folder. Okay, now let's go try to do the tests again, because it was using the wrong version of the package. I think it's... Alright. Okay, so it's still on that old one. So you should just go to Anaconda and uninstall this package. Okay. Come on. I don't want any of this. I just want to get this stuff off of root. Environments. What do we call it again? BetRisk. B. Nice. Let's uninstall. How do we uninstall? Okay, that means time to check comments. No comments. Cool. Alright. Another 15-minute timer. Back to this. Alright. Uninstall. Oh, that's easy. Conda remove BetRisk. Okay, that's not doing anything. But then if I do conda remove, the following packages are missing from the target environment. Packages missing from the target environment. Oh. Yes, remove it. Very good. Okay, so now I have to figure out what's like the setup of PyTest. Like, where do I put the test? Because it's not finding the directory anywhere. PyTest test only package. Well, that's silly. Why would you? I don't know. Reasons for everything. Okay, I'm gonna go to the bathroom and I'll be right back. That should be good. Okay, be right back. Okay, I'm back. Now, trying to figure out how to get this pi test to work. Oh, it's not finding the package. Put tests in package. The hell? Something just hit the window. Okay, so that's what I want to do. Keep tests separate from code. Oh. Tests. Yeah, it's on the same level as source. So now we could just do pip install dot. Okay. No, wait. Okay. All my life I want money and power, respect my mind or die from lead chow. Capital allocator. Then we go into tests. Now it should be 38. Martin had a dream. 40 is not equal to 38. Yes. Convert odds, get payout, bet, option, event. Get payout of odds risk times 1 minus. Okay, so make it 0. If we don't have a fee in, then we just want to multiply it by 1. Still getting 40 for profit. 0.05. Huh. Why? Oh, time to check the chat again. Okay. Good to go. From BetRisk.risk management, import bet. Might have to reinstall it. Yes. All right. So we've passed our first test. Everywhere we go. Okay, so let's make a new test. Test option.py. Okay. Test. All right. Let's forget about the tests for now. Let's just go to events. All right, so E equals event. Say Rams, Lions, Rams, Lions, 0.05. Let's make the fee nothing. Option 1 odds is 200. Option 2 odds is minus 240. E dot place bet. Alright, so first we're putting money on the Rams. And odds are plus 200. We're gonna risk 10 bucks to win 20. Okay. Now we're gonna bet on the Lions. So let's pretend that the odds swung. Actually, let's just do e.calc EV. Alright. So EV is slightly negative. That's what we would expect. Now, okay, fine. Let's do another bet now on the Lions. And if the odds haven't swung, then our EV should lower. Oh. EV is 0. Okay, so if you play both sides of a bet, you could get EV of 0, but now let's put that on. Okay. Now let's place a bet on the Lions. Say it's minus 140. We put 15 down. Now we're guaranteed a win. Okay, so we want to maximize EV, basically. Okay. So EV works correctly. Two even bets on opposite sides. Duh. Okay. Not even, we could say equal and opposite. Bets on opposite sides. Now, how do we calculate target odds? How do we calculate target odds to maximize expected value? Okay, so that's the EV. Now let's update the odds. Let's say we're heavier on one side than the other. Yeah. So it's something, I think we want probably the EV. Self dot option 1 EV we have a combined expected value for the whole thing. So I think we want to... No, because we want to place bets that increase expected value. It wants to maximize expected value. Okay, so I'm trying to figure out how to maximize expected value. I mean, we could see if a bet's going to increase expected value. We want to not only maximize expected value. Do we want to maximize expected value? So there's something we want to... There's obviously we get to a point where if we're gonna increase... If we increase the expected value by leveraging everything up, I mean, we could get the expected value of the whole portfolio. The risk manager should tell us if we want to close out a bet or if we want to keep leveraging into a bet. So for a certain event, define, determine target odds of self. Targets odds for each team. Targets the next bet to place to even out or increase EV. Option. Alright. Targets the next bet to place. Alright, so if we want to make them even, alright, so determine target odds. So and then expected value changes over time. Yeah, I'm having trouble thinking. How do we calculate the next odds we want if we have expected value? Alright, if option 1 payout is greater than option 2. Option 1 EV is equal to that. Option 2 EV is equal to that. Okay, now if option, the idea is to balance the EVs. Alright, so then we want option 2 EV to equal that. Okay, so if option 1 EV is larger, then we're looking for option 2. So the payout to make everything equal so if option 1 expected value is greater than option 2 expected value, desired payout is option 2 EV divided by 1 minus self dot option 1 dot prob. Desired odds is equal to self dot option 2 dot calculate odds desired payout. Calculates Alright, so we already have risk and we already have payout. So payout to attain is equal to payout minus self dot payout. Self. Did I reset that? No, have to reset. Check the chat. Nothing. Okay. Okay, so now payout to attain is the difference. So if okay, we're assuming that the payout we want to attain is more than our current payout. And then desired risk. I just poured something in my cup. Is equal to payout to attain divided by, so define convert probability to odds. Probability and this function converts probability to American odds. And then we could say, so we want to return, do the opposite of this. So if probability is greater than or equal to 0.5, then it's positive. Now, all right, if probability is positive, so if it's 0.5, then it should be 100. 0.75 Return 100 plus if prob is greater than or equal to 0.5. So let's just put a table here and think through it. Alright, so if probability is 0.5, it's 100. If probability is 0.67, the odds are, I don't know. If it's 2 to 1, oh yeah, that's it. Then it's 200 minus 200 point, and then it's plus 200. Okay. All right, and then plus 500. Same as 0.2, right? No. And over again. I didn't want it to end. Okay, so then we should just do fake. 1 divided by 1 divided by probability so it's just 100 divided by probability. So if probability is 0.3, oh no, minus 100. Divided by 2. So if it's 200, we end up with 100 divided by 2 times probability. Okay. No, that's not it. 1 divided by prob. One divided by probability minus 1. Yeah, we're back to that. Used to call me on my cell phone. If prob is less than 0.5, return 100 divided by prob minus 100. All right, so if we do 100 divided by 0.3 minus 100. .5 Alright, so if probability is less than or equal to 0.5, then we know what to do. Otherwise, if it's greater than 0.5, I know when that hotline bling. Alright, so is 1.5. Okay, so 0.8 corresponds with odds of 400. Good. Else return 100 divided by prob minus 1 plus 100. Okay, nice. Return 100. So if prob is less than or equal to 0.5, return 100 divided by prob minus 100. Else return 100 divided by prob minus 1 plus 100. And then in test option, let's just make another one called test conversions. Test prob from odds. Let's just make this full screen. Put this over here. Alright, then assert converts odds of minus 200 is equal to 0 point is equal to 2 divided by 3. and then test odds to prob, then test prob from odds, and then we just assert that convert probability to odds of 2/3 is equal to minus 200. So I guess so, right? Okay, now we could run our tests. I'm a man around this. Oh, hold on. Convert probability to odds. Oh. Assert test conversions int. Or we could just make it an int. Convert probability to odds, return integer. That's not okay. Check the chat. Hello, Ray. Good to have you here. And reset the timer. Okay. Now we fixed that, so let's run pip install again. Now we can test. Still failing. Integer of return val. Oh. Get rid of that. Okay, now that should work. After we reinstall. Oh, not int. We want to do round. Cool. Okay. Now, now we know we're good. So what were we in the middle of doing? We want to convert probability to odds. Desired odds equals payout to attain desired probability is equal to payout to attain So if we divide payout by risk, as it's positive, so if we want to, if we're able to risk $1, if we're able to risk $1 and we have to win $2, then the desired probability should be alright, so we have a payout that we want to attain. We have desired probability is risk divided by payout to attain. Now, if the probability if risk is equal to payout to attain, it's 0.5. Okay, now let's go back here and think it out. Put in another table. Alright, so if we have $5 to risk, we need to win $10. Then we need plus 200. Then the associated probability is that. If we have $5 to win $5, then we need a probability of 0.5. And if we have $10 to risk and we only need to win 5, then we could tolerate a probability of 2/3. And finally, let's say we have $5 and we need to win $20, then the probability we want is 0.2. So we could do it's just risk divided by risk plus return. So there would be 5 divided by 15, yep. 5 divided by 10, yep. 10 divided by 15, yes. 5 divided by 25, yes. Alright, so risk over risk plus return. Return, convert probability to odds of desired prob. Okay. If option 1 EV is greater than option 2 EV, desired odds elif option Okay, so then we could just do, then here the odds are option 1 dot self dot option 1 dot calc odds of desired payout Okay, now let's do an example here. Okay. Now let's do Alright, now let's make an event. Let's choose an event from today for fun. College football, because it's Saturday. LSU, South Carolina. What's taking this so long? Whatever, let's just do LSU, South Carolina. LSU, South Carolina. Let's look at opening odds. So it's -6 + 6. Let's just say it's minus 180 on LSU, and then plus 220 on South Carolina. Let's let the fee be 0. All right. Now let's do else desired odds is equal to none. Let's exit out of here to install it again. All right, now let's say E dot determine target odds. Return desired odds. E dot option 1 dot payout minus E dot option 1 dot risk. E dot option 2 dot prob. E dot option 1 dot prob. I mean, it doesn't matter. That's what I don't get. What? Save. Why isn't that working? Okay, good. That's returning none now. Okay, good. So we don't have any target odds now. Let's say E dot place bet. So game starting, we're gonna throw minus 180 on LSU. $10. And then E dot determine target odds. Self dot option 2 dot calc odds. Calc odds of desired payout. Oh, so we need to know what we can tolerate. Okay. All right. Now let's do it again. Determine target odds, and we have $5. So we just threw $10 down on LSU minus 180. Now we want to determine the target odds. We have $5 to throw down. Determine target on. Okay. Let's just exit out of there because it's not working. Make sure that's saved. Reinstall. Python. Nice. So if we only have $5 to bet, then we need it to be minus 200 for South Carolina. What if we have $10 to bet? Risk. Okay. Let me see. Is anyone here right now? I'm going to I'm gonna take a break real quick and make more coffee. Yeah, so where we're at right now is I'm trying to get this desired probability to work. So if we're holding a bet, if we're holding bets on both sides, you know, here's a amount of money we can risk. Now tell me what the optimal probability is. Uh-oh. Oh, is my screen not updating? At your 10, whole key, go for 20, half a key, go for 11. Aw, man. Alright, I'm gonna add my screen again. Capture card Mac OS screen capture. Tank never empty. Okay, nice. I'm gonna take it 1-2 way back. Beat her in a wave cap. Sorry, I'm just fixing my screen right now. Oh. It's kind of awkward. How do I put my screen on here? As you hit the kill switch. Okay, crop out the side. How did I run into this problem before? All right. Okay, nice. I'll be right back. All right. Warning. Stream rate is low. I don't know what to do about that. All right. So, what are we up to? Oh, we're trying to get this to return the right thing. All right. How did I put my phone? All right, so if option 1 EV is greater than option 2 EV, then we want them to be equal. All right, so the problem here is that we're saying we're trying to make the EVs equal. This is hard to think through. No new comments, okay. Desired payout equals option 2 EV. So if that's negative, okay. So now we've got a bet on LSU. Now E dot update odds. It was minus 180 in favor of LSU. Now we're gonna say it's plus minus 100 plus 110. Now we're betting on South Carolina plus 110. Before we put $18 down. Doing a little over 5. So let's put 5 down to a little over 10. All right. Option 2 pays out $550. E All right, now let's throw 20 down on LSU to win a little over 10. Now we're gonna say E dot option 1 dot payout. Nice. So $11.11 is what we have, and we're gonna need to cover 20 bucks. I'm just confused. So we threw down $20. Oh, if it swings for LSU, then our first bet was bad value. So we bet on LSU, right? Then we would want to simulate it swinging for South Carolina. So let's say then swings for South Carolina, swings for LSU. Oh, we have to say e dot update odds. Okay, now the minus 180 minus 240 280. Yeah, I did it again. Okay. Do one more example. Place bet. All right, so then we put $10 on LSU. E dot option 1 dot payout. All right, so now we have $5.50. So let's just put 5 down. E dot calc EV. Yeah. E dot update odds minus 240 plus 280. Huh. Update odds. So why we're updating odds, but we're still getting the same thing when we calculate EV? Oh, for optional one payout, but the EV is changing. Oh yeah. Okay. And then determine target odds. Order risk $5. All right, so let's update odds to now be determine target odds. All right. In here, all right, so now we want to basically do everything we're typing here, but just automate it in a script. All right, so we're just gonna make an event. Say Rams versus Lions. We're gonna say sportsbook doesn't take anything from BetRisk dot risk management. Import all. Rams, Lions. Say Rams are minus 240, Lions are plus 280. Then we place a bet. E dot place bet. And we're starting out on the Rams. It's minus 240, and we're throwing down $24 to make it easy. Now we're gonna change the odds. Now the odds swing to be more in favor of the Rams, minus 350 plus 400. And then we can say E dot alright, now we've updated odds. Now we want to place a bet. This time on the Lions plus 400. And how much do I want to bet? So I have $10 available from my bet on the Rams. So let's just say we put 5 down. Let's put 8 down at plus 400. That'll give us a profit either way. Now we could say E dot determine target odds of 5. Python 3 examples dot py e equals determine target odds. Let's print that. Yeah, so determine target odds returns nothing. All right, so if option 1 EV is greater than option 2 EV, let's just throw the debugger in here. From PDB import set trace as ST. Option 1 EV, option 2 EV, option 1 EV less than option 2 EV. Yep. Oh. Install. Okay, now if you run it, option 2 EV. Determine target odds. Okay, let's run it one more time. I'm a little confused. So we're getting something either way. Take that out. Install. So what's printing? Team. So we're getting minus 160 for the odds. Oh. What? All right, so my option dot name. Nice. So that's telling us go with the Rams. So I'm saying we got $5 to throw down. That's saying go with the Rams minus 160. Alright, E dot determine target odds. So if we have 100 to throw down, we don't need minus 160 anymore. Huh? Okay, something's wrong with how I'm figuring that out. Nice, getting more views. Does it? No, that should show if there's any current viewers, right? That's pretty good. Thanks for watching. All right. So now we want to determine how to pick the next bet correctly. So if we have E dot option 1 dot name, E dot option 1, what do we call it here? Dot payout, E dot option 2 dot risk. So we've locked in $2. E dot option 2 dot payout, E dot option 1 dot risk. Yeah, so I guess it's that we have more to gain on the Rams. If we have $100 to throw down, we would have to wait till it's plus 1250. That just seems wrong. The more money you have to throw down, the better odds you can tolerate. More money to throw down equals better odds. Okay, give me a couple minutes to walk around, clear my head. I'll be right back. Listen to a song. All right. No new comments. All right. I have this book. Just a sec. I'm going to try to find it real quick. All right, so I have this book, Algorithmic Short Selling with Python. And I've read through it and implemented some stuff. And they have a good thing. Oh, here we go. Position sizing. This guy is great. Laurent Banu. Algorithmic short selling with Python. Okay, now we go here, 171. Position sizing. Can you read that? Position sizing. Money is made in the money management module. This book's had a big influence on me for stock market investing. And this is all I think about. Is I literally just think about this chapter. Money management. Money is made in the money management module. Well, okay, then I want a money management module. Liquidity is the currency of bear markets. Averaging down. Yeah, so sometimes you want to average down, other times you don't. Okay, so he cautions against averaging down. He says don't average down. In the gambling world, averaging down is known as a martingale. Hmm. Beta. By ignoring beta at the position sizing level, volatility resurfaces at the portfolio level. Okay, so okay. So covariance divided by variance of the index return. Okay, let's look at covariance and variance. X minus the expectation of X times Y minus the expectation of Y. The expectation of that whole thing. Okay, let's go back to here. Build a money management module like Alright, and I'm using Bad News book for reference. Bad News says since investors react to volatility, it is therefore advisable to size positions according to their volatility, or beta. Oh, then it gets to the optimal position sizing algorithm. Despite the pedigree and alleged sophistication. Okay, I'm reading about bet sizing here. Position sizing. Alright, so there's different position sizing algorithms. Position sizing is not just a mathematical exercise. Position sizing is the critical articulation. Risk needs to oscillate between a minimum and a maximum. Okay, so Banu, we need to ignoring beta at the position sizing level causes volatility to resurface at the portfolio level. Ignoring beta at the position sizing level. We don't a reference index. All right, this optimizes returns over time. Not ideal because we want to sacrifice high percentage returns for guaranteed wins. So typically a fractional Kelly criterion is implemented. Kelly criterion is win percent divided by average loss percent minus loss percent divided by average win percent. And it's my turn to settle down, my concern. Nice. So the fraction of the current bankroll to wager is the probability of a win minus probability of a loss. Any chats? Pat, do quarter Kelly. Okay, thank you, Timothy. All right, Timothy says to do quarter Kelly. If you're still here, Timothy, could you tell me why? Why the quarter Kelly? It says use fractional Kelly. How do you know what fractional Kelly to use? How do you know what fractional Kelly to use? All right. Okay. So there's two things to take into account. I guess the probability of a bet changes depending on the current bets we're holding on that event. So for each event, calculate probability. Let's see. For each event, calculate. Put a note here. Timothy from stream says to use quarter Kelly. All right. For each event, at each time interval, we want to first update get odds for each event. P is the probability of a win. Alright, get odds for each event. Get Alright, so the first thing to do is get portfolio status. So see how much do we have and how much money is tied up. Then get odds for each event. Then probability of a bet changes on the current bets we're holding on that event. thing is, you can't change the size of a bet. B is the proportion of a bet. Q is the probability of a loss. Alright, so all we care about is the probability that the bet wins and the proportion of the bet gained with a win. Alright. I keep feeling stuck. So, alright, get odds for each event. Determine whether each bet, option 1 or 2, determine whether option 1 or 2 is a good bet. Take all good bets use Kelly criterion to portion to determine bet amounts. There's some sort of optimization. The Kelly criterion determines bet amounts, but so does the current odds and stake on the bet. So how do we weigh the two? Nice. Thanks for the reply, Timothy. Kelly staking is for singular bets. Oh. Sports betting, you don't know the exact edge. And presumably you have multiple bets on at the same time. Oh. Okay. Edge equals expected win percentage times decimal odds minus 1 oh, is that this? Expected win percentage minus or times decimal odds minus 1 Full Kelly staking is edge. It's for singular bets. Full Kelly staking is edge divided by odds. Well, I'm confused by that. The edge is the win percentage. The expected win percentage times the lose percentage minus the expected losing percentage. Full Kelly staking is just the edge. Oh, so the edge is the expected value then. Then Kelly staking. Alright, let's look up quarter Kelly. Oh. Fractional Kelly is full Kelly divided by 4. The decimal odds of the bet. Probability of winning the wager. So I guess that's kind of the sticking point, is how do I find the probability of winning the wager? To do that, you need to say, I mean, I'm just using the decimal odds. I guess then you can't use the decimal odds to determine the probability. I wonder, I guess if you just divide Kelly by 4, you decrease the risk. But I don't know the edge. Unless I can calculate current edge. Pat, give me a message, we can talk. I don't know how to message. That sounds good though, Tim. That would be great. Message on YouTube? Here's my email, Timothy. Oh, nice, okay. Okay, nice, thanks. Nice, just texted you, Timothy. Under, you should probably delete that when you get a chance. I wonder if I could. Oh, nice. Good. you're deleting them. Okay. Now, all right, I don't know the edge unless I can calculate the current edge. Edge is Timothy's edge thing went away. That's okay. FP, so this is the bet. Oh, BP, B times the probability of winning the wager. So I'm just going to work it out on paper. All right, so F is BP minus Q, but Q probability of losing. All right, so we could just say it equals BP minus 1 plus P over B is equal to P times B plus 1 minus 1 over B. And then B is decimal odds of bet. So .3 odds. Oh man, I don't know how to. Decimal odds to probability. Just 1 over probability, right? Three decimal odds which is the amount a winning bet would collect on a $1 bet. Okay. Oh, so the convert American to decimal. Okay. All right. So all right, and then if it's negative, minus 200 means that you need to bet $2. Okay, so minus 200 on a $1 bet means that you return 1.5. So Okay, now let's try this. Turn val. Oh. $100 divided. $100 divided by 200. I think that should work. Okay, nice. Back to here. All right. All right, so if we're using our formula, then what's our probability? Bet minus $5. Oh, so that tells you if the odds are worth taking. I see. All right. So we need so in order to use the Kelly criterion, alternative to Kelly bet. So we could calculate the current Kelly formula. So maybe what we need to do is make B the odds of the total position. So if we make B the odds of the total position, then it's telling us how much alright, we can say use Kelly for betting. F P. What's the difference between these two? P times B over B. PB minus 1 P times B plus 1 minus 1. Okay, so it's the same thing. Use Kelly for betting. Now we have an optimization problem. All right, so we know a current bet. So we want to get the odds of the total position. Guess at odds. Okay, so now we have an optimization problem. B, let B represent the odds of the total position, including all bets being held. Let B represent the odds of the total position. Now, bet amount influences B. B influences bet amount. Because whatever the bet amount is... Okay, so now we have to work out the math for that. This isn't very fun to watch on stream, but I'm not good at working out math on the computer. It's way easier on paper. So, current odds. So I was gonna say let's calculate current odds, but if we're guaranteed a win, then we're not risking anything, which would make the odds infinite. Okay, I think I'm going to leave this off here and give myself a task. How do you... figure out how to implement Kelly criterion for our situation. Okay, I'm gonna end it there. Thanks for watching. Please, if you're watching, go to my GitHub, check out the stuff I have there, the repositories. I'm working on this project there. I also have some data in there. Download. If you use Python, please use this package. Let me know what you think. Put any bugs you run into on the GitHub. Please star the GitHub. Thank you. Thanks.